The user interface consists of three different areas. This area is your real-time area. So you're going to see your building, and you can see your building in few ways. You can see it via Google Earth or Google Map, or you can see it via layout. So for example, if you go up here and you select floor 1 or floor 2 or floor 3, that will show you the layout of your floors, and it will show you all the assets in that floor specifically. So for example, in this case, each one of these is a detector, so it will show you all your detectors where they're located. It will also show you all your cameras. This is a camera icon where they are located. It will show you all your doors where they're located. A green door means that it's open. It's on time zone 8 to 5. You can click on any camera icon at any time, and you can start streaming video from that camera. So this is your basically just your display area of the real time. Then you move over here. This is the notification area. This is where you will get messages that's coming from the sensors. The sensors are battery operated, and most of the day they are sleeping. They are very, very low power. If there is any kind of snapping noise, it's got to be snapping noise, they wake up. It cannot be music or the fire alarm or anything like that. It's not going to wake up the sensor. But if there's a snapping noise, the sensor wakes up, calculate the energy level, and decide if it's a threat or non-threat. We can distinguish between a threat and non-threat in the 6 sigma range. That means that there's no false alarms. The physics behind this technology of the algorithm was developed by the Department of Energy in one of the national labs, and we licensed the technology, and then we developed all the hardware and the software to implement the physics behind it. So when we in our system, when we see a gunshot, it's a number, it's a pure number of energy, 16 million, 20 million, and based on this energy number, we can distinguish between a threat and non-threat. The sensor itself also wakes up once a day, does a self-test, and sends a heartbeat. I will show you this on the real system. The heartbeat telling the system that I'm here and I'm good to go, I'm alive. If the sensor does not send a heartbeat, you will get a text message on your phone telling you that this sensor at this location did not report in today. The sensor also have accelerometer in it. So if somebody tried to mess with it, move it, or whatever, it will let you know that. This indicator over here, this indicator is the enable disable indicator. Any sensor in the system can be enabled or disabled at any time from the menu for whatever reason. For example, let's say that you have some kind of remodeling and you want to move the sensor, you can take it off the ceiling, disable it, and then when remodeling is complete, you can put it back up there and enable it. In this case, it shows it, I think it says we have 7 detectors, 5 of them are enabled. This indicator will show you any kind of self-test failures in the detector. If the detector has as I mentioned, it does the test once a day. If there's any failures, it will show up here. This pie chart will show you the battery life of any detector. So each slice of the pie is a detector. When you click on it, it will show you that battery life, how much left on it. When the battery life is 30% or less, it will turn orange. When the battery life is 10% or less, it will turn red. The last section is the action next section. Once you put the password in right here for the user, whatever user logged into the system, at any given time you can just lock down the building for whatever reason. Let's say there's an imminent threat, you can just push this button, lock down the building. Or for example, if there's fire, you can just push this button and open all the doors. And that button will put you back to normal. This button here is the shot fire button. So this will allow you to simulate shot fired in a case you want to test the system, or you want to test your scenarios, or you want to test your messages. And there's a way to select in the system, which I'm going to show you, which sensors you want to activate, because each sensor might have a different scenario and you only test only that specific scenario. So you go to the system and you tell it, I'm going to use sensor 16, and then you come over here and you push a shot fired, and that will simulate sensor 16, and then all the scenarios around it are the one that's going to be activated, and you can test your system. Please stop me anytime for questions. Here's an example of a shot fired of detection. The system, of course, goes red. It automatically starts streaming the video from the location, and this is what you're going to see as the location of the shooter. This little target red area showing you where the shooter is. And of course, you're going to get also the text on your phone, an email. The dialers start dialing to 911, and all this is done within 10 to 15 seconds. This is the kind of text message you're going to get on your phone. You will actually have the building information, what kind of caliber of weapon is being used, and a picture of where the shooter is with the building, showing you where the doors are and then exactly where the shooter is. And every time they shoot again, it will get an update message with the new location. So the key feature of the system is the full facility lockdown. Integrate with most public address system and mass notification system. Easy to install with the capability to put the entire building or security under one umbrella. Live video streaming is accessible via the EAGL interface at any time. Real-time data dissemination provides critical information to law enforcement and building officials. Able to control multiple building and multiple scenarios, and provides real-time ballistic analysis. The system is composed of three components, really. You've got the EAGL server, which is right here, which really does all the communication and all the sophisticated algorithms. You got the gateways, which are wireless in one side, but the PoE on the other side. Our new technology, gateways, the range is 2 miles outdoor. Indoor, we don't know yet. We went 500 feet and it still was going, but the building ended, so it's at least 500 feet inside the building. There's no limit of how many fireflies can be associated with EAGL, with a gateway, and there's no limit of how many gateways can be associated with one EAGL. So for example, let's say that you got a complex with 5 buildings. You can put one EAGL, and then in the rest of the building, the only thing you need to do is put one gateway and few fireflies, and then you program the system. Each building is a different scenario, so each building is controlling his own doors, his own messaging, his own people that need to call to, and also a system have a relay board, up to 8 relays, that you can connect to whatever it is you want. In a case you want to, for example, the way we use it is we connect it to the fire alarm system. So if the intruder first come in and pull the pull down station to get everybody off the classrooms, and then he shoot, when we get the shot detection, we reverse the message. We actually stop the message and we put our own message there. In the case that he shoot first, then we disable the pull downs. Now, if there's a real fire, the smoke and heat sensor still going to work. The only thing that doesn't work is the pull down sensor. So this is, for example, what we do with our relays. You can program them for that. And I'm going to talk about the actual physics about the detectors, how it works. So in this case, as I mentioned, we are calculating the energy level. We don't care what kind of sound it is. We don't need to filter out. The traditional way of doing detection is you listen to whatever it is, and then you start filtering it out, everything that it's not a gunshot, and then it may be a gunshot. Our technology, we don't care what it is. Turns out that the energetic level of a firearm is extremely high, and it easily can be distinguished between other noises. So if we put the classification threshold right here, this is a classification threshold, you can see that the lowest energy level, the highest energy level, just below the classification, is the firecracker. And the lowest classification above the threshold is a 22 caliber. And you can see that 9mm look like that, and 45 looks like that. It's really true. It's more, the higher the weapon is, the more energetic we are getting, right? And I can tell just by the energy level almost what kind of caliber it is. In our system, a 9mm will give us about 40 million. A 22 will be about 23 million. Our classification threshold is 16 million. Anything above 16 million we consider a threat. In fact, it's so precise, you can shoot blanks, we're going to show it to you, it will not trigger the system. And then you will shoot a real bullet and it will trigger the system. But this is not enough. Once we decided that this is actually a threat, then we take a sample of the waveform, very small sample, otherwise it will take too long. We send it to the Eagle, where we have a proprietary algorithm to reconstruct the waveform, and then we're doing a bunch of analysis on it. We convert it from the time domain to the frequency domain, and then we can get the ballistic signature to see what kind of weapon it is. By doing that, we can also eliminate anything else that might be a threat, but we already eliminated that actually on the first level right here. The whole process takes a few seconds, 5-6 seconds. Okay, so this is where we are. This is the location we are in. This is the layout of this building. This is the shooting area over here. As you can see, you got the camera. I can click on the camera at any time. It will start streaming from that camera.